Alright, time for another DraftPhysics.com, debatephysics.com also, but I'm trying to find somebody with balls willing to, actually interact in some sort of, debate, argument, and hopefully mostly constructive about actual physics subjects. So we'll see if we can get anything out of this guy regarding how the physics actually works in terms of explaining why he thinks it is the way he thinks it is. So he's arguing that gravity is an illusion, which, sorry, not even close. So I guess I would like to convert that conversation into a more direct conversation about the nature of energy itself and the nature of what could be argued as, let me get rid of this, so we could just deal with mg, okay, h versus mgt, okay, and I say it's kind of obvious that the t always works. So whether you already have a velocity going into a gravitational well or you're going across a gravitational well, all right, that time will tell you exactly how much bending or movement you're going to get. So if you go through the gravity very fast, going 5,000 miles an hour, so you go through it really quickly, you're only going to add a tiny a bit, 0.9. You're just going to add a little tiny bit of velocity. But if you're just sitting here in space, then you fall and you take 10 or 20 or 30 or 40 or 50 times more time to fall, that you'll gain much more velocity. And the same is true going through a gravitational field. The faster you get through it, the less sun hits you, so to speak. That the gravity works exactly like rays of sunlight. That the more sun rays you're exposed to, the more suntan you get. And the more bending you get. And it's just about time. And so this distance thing is irrelevant, this displacement nonsense. And the only thing that matters is how long is the gravity making you, giving you motion. Now, if you're stuck on the Earth, it can't give any motion because whatever hits you goes right into the Earth. So you can't really gain anything. You just keep losing it to the Earth. But every second, the Earth gains essentially your mass times 9.8 as a pressure that it has to absorb. And that's a fact. So this is just a nonsense. And the work equation is also a nonsense. Work equals force times distance. Well, no, it's force times time. It's always about how much time. So this goes back to lots of conversations, whether you can roll across thin ice. You go across thin ice really fast. You don't break through the ice. Why don't you break through the ice? Well, because you're applying less pressure to the ice. And if you're applying less pressure, there's obviously less friction with the ice. The less time you're spending pushing down on it, the less contact you have with it, the less you're losing of your velocity. You're reducing the friction by limiting the time you are in contact with the surface. So we can go right straight to do you really believe it takes 25 times the fuel to increase velocity by 5? That's what the kinetic energy theorem says. 100 times the fuel to go 10 times as fast. Do you actually believe it takes 100 times the fuel to go 10 times faster? To spin a motor 10 times faster uses 100 times the wattage. That's what the physics says. It's nonsense, and I'd like to argue it. I'd like to see you defend it against my arguments. So I have my arguments in lots of 5-minute videos. You could choose any one of those and point out where I'm missing, the brilliant physics. I could illustrate with the ballistic pendulum, right? The bullet goes in with 2,000 joules. You conserve 98% of the momentum, yet you lose 99.94% of the kinetic energy. You can't say it went to heat or displacement or distortions, because then it would have used momentum. You can't distort something or bend it or in some way defect it, okay, without using momentum. You can't make something hot without using something's momentum. All right, so with that preliminary, we'll do a gravity video. So it's not exactly directly on the subject, but it really is, okay? The mgh thing is just so wrong. It's just about how much time you're in gravity. It tells you how much you're going to get affected by it, and it's affecting you just as if it was photons raining down on you. And they're raining down in all directions, and you're absorbing a certain number based on how big your sail is, okay? How big your surface is your mass, and your mass just collects them like you collect wind in a sail. And that's the simple counter argument to all of this, whatever you call this, this, frankly, I hate to call it physics, right? Because it's nonsense, frankly. That there's a curvature in whatever, this bent geodesic is somehow a force in the universe. It's not a force, it's not anything, it's not even a complete explanation. I mean, most of the time people are talking about bent fabrics. It's not even a true analogy. It doesn't work in 3 dimensions. I mean, it's just horrible. All right, with that said, okay, let's play the video, right? Hope for the best. So again, you know, the odds are he's going to ignore the argument. Same old bullshit as we always get. His channel's a little strange. I mean, 5 months ago, he's wearing a t-shirt in this icon that says Khan Academy. So I don't know, maybe somehow he got connected with Khan Academy. I don't know. But yeah, his videos went from 5,000 views average to 300,000, you know, in 1 month. So pretty spectacular channel growth.
This video is sponsored by Brilliant.org.
Yeah, who cares?
If you're in a free-falling elevator, you won't feel your weight. In fact, you can't even tell if you are falling or just floating somewhere in gravity-free deep space.
Right, but you're free-falling, right. So you're free-falling, the elevator's free-falling, and the gravity is this small discrete force that's actually a nuclear force. This would be one of my arguments to you. Gravity's a nuclear force. It doesn't move big objects. I could put an atom right next to me. It'd do exactly the same thing. And my argument would be is I could put an electron and a proton right next to me and it'd do exactly the same thing. The gravity is affecting the electrons and protons. And it goes right through us, hits the electrons and protons, pushes them into each other. And we can't feel it because it happens to everything. So all our nerves, everything all moves at the same speed. Because it really just matters on electrons and protons, and it's making electrons and protons move the same speed because they're all the same mass. So if all your electrons and protons are moving the same speed, and somebody's right next to you and all their electrons and protons are moving the same speed, yeah, you're not going to see any difference. You certainly can't feel the difference if the pressure is applied over every one of your electrons at the same time. No chance you're going to feel that force. But you will feel a force that pushes you up from your feet, for example. You're going to feel that one because your feet are going to change long before your head does. Simple truth.
Now, Newton explains that of course there is gravity. You do have your weight. But it's just that the force adjusts itself by some mysterious coincidence.
Oh, okay. So there's no mysterious coincidence. It's adjusting itself based on your 9.8 per electron and proton. It's taking every single little electron as the same little thing. Same thing, same thing, same thing, same thing, same thing throughout my whole body. And that's all it's moving is electrons. It's moving these things. They all weigh the same exact amount. So they all move exactly the same speed. So what's the complication? If I have more electrons, I fall with the same speed as something with less electrons because it's the electrons that are moving, not the number of electrons, the electrons. So if you have an electron, it's going to move. If you have 1 electron, move the same speed. 10 electrons, they all move the same speed. 4 million electrons, you move the same speed. 60 billion trillion electrons, they all move the same speed. So it doesn't matter how many you have. It just matters that this is what's getting pushed is the electrons and protons. So it isn't mysterious at all.
In such a way that everything falls at the same rate.
Because everything is made out of the same thing, electrons and protons. And they're the things falling in the gravity.
That's why you get the illusion of being weightless. And Einstein comes along and says, what if there's a simpler explanation? Maybe
it's not simpler, it's a cop-out. There's no force, there's no mechanism, so it's just like saying the magic makes things move. Magic makes things move. That's all it's saying. It's not saying anything. It's not physics anyway. It's not physical.
there is no gravitational force, no mysteries. What if they're actually floating in space and it's the ground that's accelerating up?
All right, so just a nonsense. Obviously, the ground can't accelerate up. As we know, there's people on the other side of the Earth. They're not accelerating. It's not getting bigger. We know all that crap ain't happening. The whole universe isn't expanding to facilitate the illusion that we are. The moon doesn't get further away because to satisfy our illusion that the Earth is expanding. So none of that crap can have anything to do with the truth. So why play with that idea? Absolute nonsense.
This is elegant, but there's a big problem with this, and a lot of you asked that question in my previous video. The problem is Earth is round. So if the ground is accelerating up, does that mean that the Earth is expanding? Well, clearly not. That can't be true, so what's going on? Well, that's the question.
So now they're going to pretend it is actually expanding and we just can't see it? No, I don't know what he's going to say. It's just nonsense. The clear truth is that the Earth is consuming energy. So more energy is on the outside than coming out of the Earth. And that differential is what needs to be explained. Why is there a differential? Why is there less energy coming out of the Earth than is going into the Earth? And the simple explanation is, well, because you're moving electrons and protons. The Earth is full of molten stuff and it's all moving around doing this, jiggling. All that jiggling is using up the speed of force. So stuff the speed of light hits the electrons and protons. It makes them move, that is, it sticks to them and moves, and it moves a lot slower. So the force is going the speed of light, and then all of a sudden it's only going 10% the speed of light. Or 20%. It's not going anywhere close to the speed of light anymore, and that's the differential. So the force goes in with all of its speed of light integrity, and it's coming out after it's been essentially slowed down, pushing electrons and protons. That's the differential. I'll argue that's going to be the truth 100 years from now. Okay, 100 years from now, everything you're saying, nah, sorry. Okay, it ain't gonna cut it.
Question we're going to try and answer in this video. And in doing so, we'll actually discover the ideas of curvature and find a way to visualize it. No, I'm not talking about that analogy, that model.
Yeah, this nasty, stupid analogy where you use gravity to explain gravity. Yeah, that's really bogus.
In which we stretch a sheet and then use a ball to represent the Earth deforming space-time and the moon over there.
Yeah, well, that's the actual truth. See, that's an example. What happens? You have too much velocity going in, you're flying straight out. You have too little, you're going straight in. There's no orbits, unless you change your velocity.
Come on! And we throw a moon over there, to represent the orbits and everything. The problem over here is we're using gravity to explain gravity.
Yeah, exactly. So nonsense. But this silly idea that you're coming up with is even worse. So let's just say that up front. Some notion that there's an illusion somewhere. There's no illusion. It's really obvious what's happening to us. There's more force coming down than force going up. It's obvious.
Over here. Instead, we'll come up with a much more accurate visualization where we'll see it's the curvature of time that plays the major role over here. So
nonsense. Just absolute nonsense.
If you're ready for this, let's begin. So where do we start? Well, we can start where we left off in our previous video. No, you don't have to watch it
yeah, thank you.
As long as you followed me so far. But in the previous video we saw using Einstein's equivalence.
Oh yeah, I wanted to play that anyway because it's absolute crapola. So again, you're going to actually defend the Eddington experiment. Is that what you're going to tell me you're going to defend? We don't have it done beyond the margin of error. So no one could repeat the experiment outside the margin of error. All right, so all you have is a 1919 experiment, okay, where everybody knows the weather conditions were horrible. He admits in his journal he got 10% of the data quality. So he was hoping for 10,000 stars per slide. He got 1,000. That's a written fact. All right, it's a fact that he also said I wouldn't stake my life on these results because he knew his data was that bad. So you're telling me that light is twice as bent. The lightest, fastest thing in the universe is somehow magically twice as bent as all the rest of this shit. I would say no force is ever bent by gravity, so why would I think light is bent by gravity? That's like thinking light can bend light. Light can't bend light. You need a medium. Forces can't interact with forces. So that's the simple truth. Gravity doesn't interact with magnetism. Magnetism doesn't interact with gravity. This doesn't interact. Those old things don't happen. So the forces are inert to each other. just a fact. You're claiming otherwise with just about zero evidence, right? And in the 50 years we've been in space, or 60, they never even tried the experiment. So you don't need an eclipse from space. It takes 5 minutes, and you have 400 times better viewing resolution. Not 4, not 40, 400 times better viewing resolution. And yet they haven't even tried it from space. You think that's a plausible scientific statement, that one of the most famous experiments in the history of science was never repeated from a place where it's 400 times easier to do, and it cost 70 cents. And they never even tried it. You think that's plausible? I think that's ridiculous.
Principle where he said gravity is equivalent to your ground accelerating upwards. In that model, we found that the light must bend. But the problem is, if light is bending, just like how in a circular track the outside...
So obviously it's not bending. The light goes straight across the spaceship. It has no reason to do any bending thing. It goes straight across at the speed of light. It doesn't go a longer path. It goes straight across. The only thing you're doing is moving the target. You're moving the target. The light's not moving anywhere. The light's not doing anything extra. You're just moving the target. The target moves away. The light goes where it was going. You take the target and move it there. Yeah, the light went over here. It didn't go over there.
Outside distance is more than the inner distance. Over here, this outside distance, light travels more distance compared to the inner one, but in the same time, which means...
So again, it doesn't happen. I mean, I'm not going to draw the light clock. Done it. Been there, done that. But the obvious fact is the light does not travel the crooked path. The light photons move in a straight line, okay? They don't decide, hey, you're moving the target, I'll go with you. So I'll go this way and this way. A photon can't do two-dimensional motion. It can only move in one dimension at the speed of light. Can't move in 2 dimensions at the speed of light. Can't go this way some speed and go this way at the speed of light. Can't do it. So the whole thing is bogus.
The light over on the outside is traveling faster than the light on the inside. This violates Einstein's own postulate, which said that the speed of light must be the same. But over here, look, the speed of light is not the same. So Einstein, it's going to be super hard for you to get out of this one, isn't it? And Einstein says, well...
Yeah, it's fairly irritating when people talk to the dead people, and mock them. Well, the dead guy can't defend himself. But whatever. The theory's garbage. Okay, that's my opinion. Right? Just complete nonsense. It doesn't explain anything. It's a non-theory. He might as well have said Gremlins did it.
Actually, Mahesh, it's going to be super easy. Barely an inconvenience. Really? How? Time dilation. What do you mean?
It's time for better internet. Switch to extra.
I knew that was going to... All right, back. All right, so he starts the sentence with Einstein asked, well, the simple point is it's going to try to pretend that you can change the physical reality, and you can't change that. You can only change perceptions. You're going to change viewpoints. You can't change what physically actually happens. So I could have 2 simultaneous events. All right, two flashes, 2 supernovas. And you could have lots of conversations about, well, if I was way over here, I saw this one first and I saw that one second. Or if I was over here, I saw this one a little faster than that one. Or, you can change your perspective and say, look, the signal took a while longer to get to me. The event didn't take longer to get to you. The event didn't happen in some different space. It's an absolute truth what the event is doing. So this doesn't work, this comparison about one beam of light relative to the other beam of light. The 2 beams of light are in fact going to reach the same location at the same time. So there's no way one of them could have gone slower. All right.
Who is running faster in these 2 clips? And I say, well, Einstein, actually, they must be running at the same speed, the same clip. You have slowed this one down. And Einstein says, exactly. Just because you see something slower doesn't mean that the speed is less, isn't it? Here,
you can't change the reality. I'm just saying, if you were accelerated to the speed of light, we all know if there were windows on your spaceship, you would see the rest of the universe moving really, really fast. Everything would be zooming happening, okay? If you had a video camera from Earth, the video signal showing the images of the Earth would show the Earth getting wrinkled and getting old and, farting a lot. And it'd be a truth that, oh, wait, a whole bunch of time is going by. Okay, maybe it's not going by for me. I'm not seeing it. But frankly, if you could see the rest of the universe, you'd see it be happening. So we know it's happening. So why pretend that this slower speed is real? You're not actually traveling a slower speed, okay? You're traveling the same amount of distance in the same amount of time, and it just doesn't make any difference whether you say your clock is ticking slower. It doesn't change the fact that you're moving really, really slow, that you have to physically actually move slower, and you're not going to be doing that. You're not in some time capsule where you get to, hey, everything's happening really slow here, and then the universe is going speeding by. Everything happened at exactly the same time, okay? So it's just bullshit.
He's running slower because the time itself has slowed down. Not because his speed is less, his speed is the same, but the time has slowed down. Maybe the same thing is happening over here. Maybe the light is traveling at the same speed, but the time over here has slowed.
So anyway, this whole bent thing is wrong. Neither beam gets bent, so that's what's wrong with this analogy. Neither one bends down. It doesn't happen. The photons go straight, and your surface is what's moving. All right, so your photons aren't going to hit the target. That's the truth. It's going to be way off, but they never bent. All you did was move the target. Oh, shit. If you were in the spaceship and you could see the photons going, doing their progression, right? You'd say, well, gee, they hit the side of the spaceship way below the target, so it looks like a bent line to you. But that's only because you're not seeing the fact that it's going straight. And you're the one moving. You're the one changing how it looks.
Slowed down. Therefore, the light travels less distance, but in less time. And that's
So no, it always gets there in exactly the right amount of time. The light travels the speed of light from the two surfaces at exactly the speed of light. It doesn't go any faster, doesn't go any slower, and it travels in a dead straight line. And the curvature, any notion of a curve, is completely your fault. Your perception was garbage. You saw it wrong because you moved, not because it did anything unstraight. It did everything perfectly straight. You screwed it up with your limited perception.
way the speed can still be the same, isn't it? And looking at this, I say, well, Einstein, you basically come up with stuff just to ensure that your speed of light postulate doesn't break. And Einstein says, yes, that's what we've been doing since our special relativity days. But
yeah, that's right. That's right. It's all just a word and gimmick game, and then come up with these, somebody points out how, well, how did, where's the invisible man's DNA? How did the DNA code get invisible? I mean, it's one thing for the DNA code to say everything else is invisible, but how can it make itself invisible? And they come up with some nonsense, about how somehow the DNA molecule knew how to make the chemical that made everything invisible.
let's think about what this means. This means that clocks at different heights should run at different rates. Clocks which are higher should run faster, and the clocks which are closer to the ground should run slower.
Yes, and it's exactly how it turns out, because it's really not about running clocks. It's about velocity, and the thing in the deeper gravity is oscillating more. The harder the gravity, the more oscillations, the more aggressive the oscillations. If you're going into the earth pushing you back, the more pressure, the more voltage, and the higher the oscillating rate. And the further away out in the gravity you are, the less you're oscillating. So as you're moving this way with velocity, you can just figure it out. Basketball player, 6 miles an hour. Basketball, 45 miles an hour.
So we have time dilation, a different kind of time dilation. This is called gravitational time dilation. And what's interesting about this is that
This is the only one that matters. This is the strong one. The weak one is the velocity one. So the fact is the clocks on Earth are the ones moving too slow. They're the ones time dilated. And the clocks on the satellite are the ones running too fast. So this gravitational effect is the strong effect.
Your head is slightly farther away from the ground compared to your feet. Your head ages faster than your feet. But how much is that age difference, if you ask?
So none of this spaghettification thing's ever been proven, because the rate, the amount of gravity that's going through you is going through you in all kinds of ways. So if you're in this position, the gravity is going to hit you a lot this way, this way, this way, this way, this way, from an angle. And if you're in this position, you're not getting any of that angle stuff, right? So all the stuff coming at angles this way, you're missing. But you're getting a lot more of this, okay? So you're getting a lot less of this, and you're getting more of this. And if you're this way, you're getting very little of this, but a lot of this. So there is no spaghettification. So if you make it a actual R squared photon synonymous force, you're going to get the same exposure whether you're this way or this way, because the photons are coming from all angles. There's a sun over there, and a sun there, and a sun there, and a sun there, and a sun there. So you can't really hide from the light.
Well, for that we have an expression, and I think Epstein in his book Relativity Visualized, which I highly recommend, it's an amazing book, has derived it just by using that whole curvature of light from where we actually thought about
amazing.
right?
Somebody actually,
just by using algebra.
Somebody drew this stupid illustration of the bending light photons, when you could do the experiment with a single photon and all of that nonsense goes away anyway. So I mean, what, and the light never bends. So again, this whole argument, somehow the photons can have two directions. The photon can go this way at the speed of light, and somehow it can go this way at some other speed. No, it can't. It's a photon. It's a one-dimensional line, okay? It's going in one direction. That's it. It can't do two things. It can only do one. It can only have one velocity in one dimension. It can't have two-dimensional velocity.
Right, there an expression which I feel is insane if you think about it. But if you plug in the numbers over there, you'll find that your head is actually going to get older older than your feet by 1 second every 100 million years.
All right. So again, and that's on this premise, some false premise, that the gravity isn't a real force that's coming from all directions. And if you understand that, then your head isn't going to be any different than the rest of your body. You're not going to get spaghettified. And it doesn't matter anyway, right? As he just pointed out, it's a 1 billion to 1 kind of thing. It's just not even important. Why even bring it up? You could almost argue, why bring up these subtle differences when the only thing to understand the important differences is why is the satellite, which is going 23,000 miles an hour this way, why is that clock running faster than us on Earth going 1,000 miles an hour? And the reason is simply because we're Elysing. We're bouncing a lot more per second than that satellite is.
April 3rd, Disney will be hosting its annual meeting of shareholders.
Sorry. I didn't realize it was a commercial. I can't tell the physics from the cartoons.
So this means the time difference on Earth is very, very minuscule, which is very convenient for Einstein. But if you go close to a black hole, it will be more extreme, and now interstellar will make sense. But, wait a second. Look at what this means.
Okay, so no, he just said something that's just not true, that the time dilation gravity thing is minuscule. No, yeah, there's minuscule difference in the gravity between your feet and your head, but there's not a minuscule difference between 9.8 meters per second and 0.00009.8 meters per second. So where the satellite is a lot less gravity than where we are. That's the difference.
Means for the very first time, Einstein's model is predicting something that Newton didn't. Gravitational time dilation is a new thing, and so we can test it out to see which model actually.
So let's understand that Newton was pretty clear. Okay, he was hard defending. Okay, he even did the bucket experiment just to point out this whole frame crap is crap. Okay, it was the first experiment he described in his book. The first thing he talked about was the fact that there's absolute space, there's positions in space, positions don't go anywhere, and the matter and the force moves to the positions. Okay, the matter and the force is doing the moving, the positions aren't going anywhere. And he was explicit in saying he's a three-dimensional universe person. There's up, down, left, right, forward, back. There's nothing else, okay? 3 dimensions of space, and you can be in places in that space, and that's it. There are no frames that change anything, and Newton would concede that, yes, It takes a while for a rock to get to somebody. If you have to throw the rock a longer distance, it takes a longer time to get to the person. So if you're sending information, yeah, information will be retarded. Okay, but facts won't be. Real positions won't be. Nothing's going to move closer or further away to accommodate your will to perceive it differently.
It makes more sense. And we did. How do you test it out? How do you find evidence for something which is so minuscule? Well, here's how we did it earlier. One of the first tests involved taking a giant tower, and you have two clocks. This clock is running slower compared to this one, but that time difference is very minuscule on Earth. But
so this is meaningless, right? Because who's contending this part of it, right? That gravity is different in different locations, and you could measure that difference in the gravity. So that's not surprising at all. So if we're going to argue that the bouncing in gravity affects clocks, then yeah, okay. Put the clock in some other place, it's going to be affected by the bouncing. So you could probably do that with actual just isotopes themselves. I mean, radioactivity might actually be, the fact is something might become more or less radioactive depending on the pressure it's under.
instead of comparing the clocks directly, we send a light signal from here to here. Let's say we shoot a light where the two waves are 1 second apart. Again, taking very simple numbers over here. Then what will happen? Well, the speed of light is the same, so they will travel all the way up, and over here also they will be 1 second apart. But remember, this clock is running slower compared to this clock, which means when 1 second passes over here, more than 1 second passes over here. Now again, just for understanding, we'll take simple numbers. Let's say this is 2 seconds. Yeah, it's going to be way less.
Yeah, that's right. They're going to use clocks that are counting trillionths of a second or whatever they're counting. So blah, 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 blah. You have to trust them, blah, blah, blah. But the simple argument is clocks break. There, we're done.
Other than that, but just for understanding, that takes 2 seconds. Then, although folks over here will say, hey, the two signals, the two waves are 1 second apart, folks over here will say, these two waves must be 2 seconds apart. In other words, if you look at the frequency over here, it is 2 waves per second, but the frequency over here would be 2 waves per 2 seconds, which is 1 wave per second. This means when the
So is nothing like this dramatic and obvious, so blah, 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 blah.
light travels up, its frequency reduces. And in light, when frequency reduces, it goes towards red end of the spectrum. In other words, we get a red shift due to gravity. This is something that we did not predict. So if Einstein is indeed right,
So, and again, I would argue he didn't predict it and you don't really see it. So you're just assuming the red shift based on the broken clock. So again, why, what are we arguing? No one saw any red light or any of that crap. So none of that actually happened. So again, this is like the muon experiments and a lot of other experiments they do where they, make up a whole bunch of crap. Well, the atmosphere weighs 400 lead bars. So we'll do the experiment with 100 lead bars at the top and 500 lead bars at the bottom and blah, blah, blah. So all the gimmicks that go into these experiments. It's not this simple. And it didn't happen, frankly. There's no evidence that light is redshifted by gravity. It's redshifted by atmosphere. Scatter redshifts light.
should see gravitational redshift. And we saw it. You can Google pound replica experiment for more details, but we actually found this.
Okay, so you say so, okay? Just like you say when you shoot silver atoms in a Stern-Gerlach experiment that somehow you're seeing electrons spin. You say lots of things, and it's all based on you extrapolating a whole bunch of your theory into the mechanics, and it really isn't in the experiment itself. So again, I could go through the whole double slit thing and explain to you how the math doesn't even work for two waves coming out of the double slit. Two waves can't make the double slit pattern. Can't physically do it. Certainly not from the mathematical position of in between. If the wave centers are the center of the two slits, that math won't work at all. It won't get the envelope pattern right, and it won't get the little pattern right. It doesn't get either one right. So this is all bullshit.
And today we have even more direct evidence. The clocks on board the GPS satellites, they need the gravitational time dilation correction, otherwise they wouldn't function. So
now, they need a correction, so that's where the guy who actually made millions of dollars in GPS okay, conceded that they don't bother doing Einstein's equations. They just turn the dial on the clock until the two clocks match. They don't bother with any of this crap. So it doesn't prove the theory. It just proves that clocks do run differently in different conditions. And I guess I could argue that we've already proven that with just about every clock ever made, that there's a way to break it, where it don't tell time very well.
I have plenty of evidence today that gravitational time dilation is indeed true, which means Einstein's model is indeed more powerful compared to Newton.
So just bullshit. I just think I should say something about this nonsense of proving Newton wrong and all this stuff. Newton, okay, wrote all this stuff in like 1685. Okay, by comparison, his knowledge base was minuscule compared to ours now in terms of understanding electrons and protons and all this other stuff. And I'm sure if Newton was alive, yes, he'd still be saying things like, what do you mean? You added up the mass of the electrons and protons and they don't equal your weight? Well, then what do you think is weighing? What do you think weighs something? It has to be matter. Matter weighs something, okay? Force doesn't weigh anything. You have to be weighing your matter, not some magical stuff that you can't, quantify.
What really blows my mind away. That tiny difference, that gravitational time difference between your head and your feet, that's the one that actually allows the ground to accelerate without the Earth expanding.
Okay, so isn't that just absolute nonsense? So they're saying that the surface of the Earth is time dilated, that somehow that time dilation means it actually moved when it didn't move, and it sometimes moved into you, and then because you're not time dilated, you didn't move in with it, or it doesn't make any sense. It moved, but it didn't move. It either really moves or it really doesn't. I mean, this is just such. Why not just talk about hobgoblins and fairies and pixies? I mean, this is just such a fable.
How you ask? Well, it's just the same way how you can accelerate your learning without having to expand your wallet.
Oh dear! So now he's going to do a commercial. Fuck. Sorry, but it's just such crap. Yeah. Just such crap. Okay, it's bad enough. They have all these ads, and then you're sitting there doing this fucking whatever it is, sell your soul to the capitalist machine. Just eek. Sorry if you're offended, but this ain't how science shouldn't be a commercial product. It's almost like again, should we pay the ancestors of Salk and the other guy for penicillin? I mean, should we pay an forever intellectual property fee? It's just disgusting.
So how exactly does the gravitational time dilation allow the ground to accelerate up without the Earth having to expand? Well, for that, we'll go back to Epstein and his book, Relativity Visualized. He says, well, Mahesh, since this is a theory of space and time, let's draw a space-time diagram. Now, remember, in this space-time diagram...
nothing has anything to do with reality. Okay, so this is, again, just a fake drawing about things that don't really happen. And that's all it is. There's no point. I mean, really, right? Is there any point in me continuing on and on and on? Let's see. Well, here he's going to do something with paper. All right, so we're just going to, we'll play it, but it's just nonsense. Nothing does these things. Again, the photons do not bend. They do not travel a curved path. They do not move in two directions at the same time.
Everything travels at the speed of light. For example, when objects are at rest, let's say when an apple is at rest, it's rest in space, but it is moving through time with the full speed, the speed of light.
So again, what are you talking about? It's moving through time. What does there's no time dimension, and it's certainly not moving through at the speed of light. What the hell is that crap? Anyway, it's just it's pathetically silly.
Moving through time, 1 second in my clock will be exactly the same as 1 second in that Apple's clock. So its proper time ticks at the same rate as my clock because it's completely moving through time. So 1 second, another 1 second.
So we know that's happening right now, though. I know right now on Jupiter there's events happening, and they're chemical events or they're physical events, and they're happening exactly at the same speed it's happening here. There's no difference in the speed. So we know if I put a clock on Jupiter, we know it's going to tell the same time in the sense as if I take it out of, gravity being a huge influence, and we know it's a tiny difference anyway. The same events are taking the same amount of time. There's no magical difference. And I could take it a zillion miles away, and the same thing is going to be happening. Events take the same amount of time, 14 billion light years away from here. The same events take the same amount of time. There's no difference. There's the same time in all locations of the universe has the same amount of time. You can't take time away and then add time over here. You can't do that. You have to conserve time. Oh, and whatever. It's just such junk that this is what people buy as an explanation. Photons can move two ways at the same time. They can go left 50 miles an hour and they can go straight ahead at the speed of light. No, they can't.
Another 1 second. Another 1 second. Look at the clock over here. Another 1 second. We'll stop over here. Okay. Now, what if the apple was moving, say, a little bit to the right in space? Well, in that particular case, some of its velocity is directed to space, and now a little bit of its velocity is diverted through time. So it'll start ticking slower. Let's look at it. It's going to go like this. But remember, that vector should have the same length because this is the speed of light. Everything travels at the speed of light.
Okay, so it's the speed of light in space. So it should be the speed of space, whatever that would be, right? So obviously the photon doesn't do this. It can't go this way and that way. It can't do it. It has no capacity to have more than one momentum. It can only have momentum in one vector direction. It cannot be parsed into two vector directions. It doesn't have motion in two vector directions. You can't move a photon to the left and then fire it at the speed of light in a direction and it still moves to the left. It doesn't do what matter does. Matter does that. Force can't do that. Force can't have a velocity this way and then add a velocity this way. Matter can do that. Forces can't do it.
Okay. And as a result, you can see its time, the time over here, its time is less. It's ticking slower compared to our clocks now. So after 2 seconds in our clock, it is still less. You can see we keep on doing that. And after 5 seconds have gone in our clock, look at its proper time.
So we know it just doesn't happen. So again, if this was the light clock, they're arguing that the light does this, when what it's really doing is a line this way, and then the line is over here, and then the line is over here. Our perception is moving it sideways, but it actually got to the other side in these 5 units. That's it. That's all there was. 5 units of velocity, whatever you want to call it, distance at the speed of light. It went those 5 units at the speed of light. This never happened. And if this did happen, it still would have to reach the other side at the speed of light. You can't change this part. This part of the equation cannot be bent or changed. It reaches the other side at the speed of light. So you'd have to argue it moved faster than the speed of light here. So it's just silly. It's silly. This is not science. This is just try to engineer a fake solution. So now you've given forces properties that they've never seen a force ever have. No force is able, no radio wave, no anything you could talk about, no photon. Can we make a photon go this way and this way? We can't make a photon that goes this way at the speed of light that way. No, it doesn't do that. They can't have two vectors of motion.
Its clock is showing how much? Well, let's look at this. It's showing a little bit more than 3 seconds. Now, this is nothing new. We've done this before. But there are 3 important things that we need to understand from this. 3 important features of this.
Yes, that it's a gimmick, that it's bullshit, that it breaks all notion of what forces actually do. Again, even the very notion that light is bent by gravity. It breaks every single other experiment ever done on any force ever. That any force can interfere with another force. There's no capacity to make a force bang into a force. We can't make photons bang into photons unless we stick matter in and allow them to bang into the matter and affect each other. But other than that, they can't affect each other. Forces can't bend a force.
The first is that this length and this length will obviously be the same, which means the path length in this spacetime diagram will always stay the same. The second thing is that path length represents how much time has ticked in our clock. To understand how much time has ticked in their clock, their proper time, you need to look at this axis. So for example, its proper time is so much, which is the same as our clock because it's completely moving through time just like us. But look at this one. Its proper time is only so much because it is moving through space. And third, if the paths are a straight line, that means the velocity has remained the same direction, which means it's not accelerating. So straight lines are non-accelerating paths or inertial paths.
Whatever. So more nonsense. We know that the velocity of the photon is the speed of light, and frankly, we know it can't move two velocities. It can't have two directions. It can only have one direction. A baseball thrown from a train can have two directions. All right, you can be on the train. The baseball has momentum in this direction. You're not going to lose its momentum in this direction. You're just going to add momentum in this direction, and you get a new vector that the baseball travels. All right, so it's a simple truth that the baseball can add the two vectors and go an increased speed. But photons can't do that. Can't do that.
Which means if something is accelerating, it will be curved. That's how we would know it's accelerating or not. Now with all of this, there's still one tiny problem. You see, over here, time is represented as a physical dimension, but that's not how we experience things. So is there a way to make this visualization more aligned with how we see things, how we experience things? And Epstein says, yes. How? Well, he says, first draw it on the
Okay, so this will be some kind of silly shit where he sticks a fucking pencil through the piece of paper shit. Some wormhole nonsense. Alright, so here he's going to bend a piece of paper. Okay.
Piece of paper and fold it into a cylinder. And the moment I see this, I'm like, ooh, is this curvature? Is this space-time curvature? And Epstein laughs and Einstein laughs at me and says, kiddo, come on. He says, no, whether you fold it into a cylinder or you crumple it, I shouldn't have crumpled it. But whatever you do with that paper, that's not going to change the fabric, the internal fabric of how the space and time are weaved together. Kind of like your dress. When you fold the dress, it doesn't change the design of the dress, right?
The dress? Guess that's a cultural thing. Yeah, I've never folded my dress.
If something is curved, which we will see later, the design itself changes. So, since curving it into a cylinder doesn't change the design, we are still dealing with the same space-time.
Alright, so what the fuck good was this stupid thing here? What was the point of this? I don't know. That really illustrated everything for me. Yep, boy, that sure does explain how photons can travel two different momentums. You know, it can have a momentum this way, and it can have a momentum that way. Yeah, sure. It's a photon. It can do that.
Thing has changed. But then what's the point? Well, Epstein says, now look. The whole cylinder represents our spatial dimension. And this curved part represents the time dimensions, kind of like a clock. So this apple, which is stationary in space, now actually looks like it's stationary in space because it's going to be there in that cylinder. It's going to be at the same location on the cylinder. But look at this blue apple. Since it is also moving through space, you see it moving on the cylinder forward. So this is much more like how we experience.
So again, what you see is irrelevant, okay? That's just the truth. Like I said, if I could make the light clock and we could make it visible and you could actually see, the fact is that you shoot the light out of the side of your ship and you're going this, the speed of light or whatever. And so you could watch the photons not make it to the other side, right? The target. They're going to miss the target. The target's going to go up, you're going to go up, and the photons are going to keep going straight. And yet, any one moment, if you could see photons being extracted, like smoke, and you could watch some of the photons being pulled out. Yeah, they're going to look like they're being pulled out, but it's still a straight line. The light traveled a straight line, straight little tiny. If I could break them into little tiny single photons, or I could break them into little Planck distances, it's a bunch of little dotted straight lines. The light never went crooked.
Against the spatial and temporal dimensions. But there's more. Remember, this length was 5 seconds. So this means in the cylinder, this one full.
I mean, as the light's going across and you're moving, the light's going to go lower because you're moving. The light's going straight across. The light's not moving. You're moving. I mean, do you need to say anything more? What you see is not what the light is doing.
Circle represents 5 seconds. So this is awesome because every circle now is 5 seconds of proper time. So if you again look at this apple, which is this one, and you look at the blue apple, which is this one, then you see this apple has finished its 5 complete seconds. It's kind of like a clock, right? On the other hand, if you look at the blue apple, look, it has not finished that full circle. It's only here, which means it has not finished its full 5 seconds, just like what we saw earlier. So it finished about.
Yeah. It's short. So so this line gets all the way back to the point. This line never hits this line. Okay. So what's your point? Oh, brother.
3 seconds or something. So you see, this is much more like how we experience space and time, isn't it? Okay.
I don't even know how that was anything to do with anything I personally experienced, and I'm smart enough to know, again, that there could be 2 events in space somewhere, and it happens at the same time, and I'm getting the information slowly. So, I mean, we all know this from, like, sound, right? We can do this with sound. We can put something very far away, and we can put something very close. We could have them explode at the same time. We'll hear the sound from one really fast. We won't hear the sound from the other one until there's a huge delay. And we can figure out that, well, that doesn't change the fact that they happen at the same time. We'll see them happen at the same time because the light's so much quicker, and we're not going to see any of that delay problem. And we'll hear the sound being way delayed. I mean, they saw that with the nuclear bombs, right? They blew up the nuclear bombs. They see all this shit happening. And it isn't until much later that all of a sudden they hear it happening. I mean, duh. We know our perception is not accurate. It is not that the reality is broken. It's our perception isn't accurate. It's not giving it's not going to give you a fair view. Your perspective matters. If you look at something you can take a painting. This is a great thing about, if you're at all ever done any painting, is that you can turn your painting and you can look at it at an angle and you'll see defects and flaws so much easier because you've changed your perception. All right, and it's you'll look so much different, and the lack of symmetry in one dimension will become much more exaggerated, or a lack of symmetry in the other, depending on which way you turn it and look at it, because you can see expansion and contraction in one dimension, you can't see the ones in the other dimensions. So it heightens your capacity to see details, because it eliminates the noise, of all the information, and gives you just one kind of information, more of one kind and less of another kind, to explain that. But I'm just saying, obviously our perception is more complicated, than just saying whatever we see is the reality, because we see it broken, in time.
So now, let's consider another space-time diagram where you have 2 apples, let's say, moving like this. What does it mean? You can probably tell now. Well, this basically means that the 2 apples are at rest in space. They're completely moving through time, and they'll be ticking at the same rate and everything. And if we roll them into a cylinder, again...
I don't even know what all this... So. The fact is the universe runs this way. And the fact is our perception distorts it. Period. Everything has the same clock is, in fact, everywhere. Events happen in the same sequence and at the same amount of period of light moving the speed of light, the same amount of time. And you can't change that. You can't be in a special frame.
That's what it would look like. But now comes the big thing, big moment. What if we introduce Earth and keep the apples over here? How will this diagram change? This is the part where you need to pause the video and think about it.
Oh, fuck. I don't know how this is Earth, but whatever.
Let's think about all the features. We know since both these apples are in space, they will not spiral. None of these will spiral. They will still be going this way. So that's the same thing. However, we now know gravitational time dilation, which means time is moving more slowly for this apple compared to this one. So, if this apple has finished one full circle, this apple couldn't have finished a full circle. It couldn't have, because its proper time should be...
Oh, okay, so he's going to turn this into a cylinder. So he's going to squeeze this circle and expand this circle or something. I don't know. It's just too ridiculous.
less than the other apple. But how can that be? Because the path length should be the same. So I want you to think about it, folks.
Be the same. And again, the argument is they're telling you that photons can move in 2 dimensions at the same time. That a photon can go the speed of light this way and some other speed that way at the same time. All right, so just be clear on what they're claiming. So just like when they claim it takes 100 times the fuel to go 10 times as fast, it's bullshit. Okay, they're claiming something that they really don't have any evidence that that actually happens. Okay, that claim can be defended, and the absence of evidence for them becomes a decisive argument, because I can't prove, I can't show you the light clock. I can't do the experiment so you could actually see that the photon gets to the other side at exactly the speed of light.
How can this, because this is the moment of truth, how can this apple have the same path length as this one and yet make sure it hasn't finished the full circle? How can you modify this diagram to incorporate that?
I don't even see any diagram. I don't see anything in here that makes any sense at all. So I don't know what the fuck this cartoon is even doing. This is the ground. So the ground, the whole thing is sideways. So the ground is this way. I don't even know what the hell he's doing. Oh, fuck. He's running a lot of commercials. That's what he's doing. Jeez. I do hate this planet.
We have to have a bigger cylinder over here. Think about it. If it's a bigger cylinder, I can have the same path length and it will ensure that it will not complete a full circle. And since it does not complete a full circle, it has not finished it's 5 seconds. So this is how Earth modifies our space-time cylinder.
Whatever. So what is this? It's just such. Sorry, I don't get it. I don't see anything here that demonstrates or proves anything or any kind of analogy or anything. Okay, so the bottom line is, again, just for clarity, you're claiming photons can move in 2 dimensions at the same time. They can have a velocity in this dimension and they can have a velocity in that dimension. I suppose you think they can have a velocity in a 3rd dimension also. And I claim no photon can do that. No element of energy can do that. No piece of energy ever that's moving the speed of light can move in 2 dimensions at the same time. It can only move in one clear vector of dimensional space.
But even this is not accurate, because this means that all the clocks here run at the same rate, and then suddenly the clocks here will run at the same rate. But of course, this can't also be true, because this diagram means clocks all over here will run at the same rate, and then suddenly there's a jump over here, and again all the clocks here run at the same rate. It can't be true. Since the clocks will gradually, the time dilation is happening everywhere, that means the radius of the cylinder should become bigger as I go from here to here gradually, which means you will get a shape something like a cone. This is how our space-time diagram has modified because of Earth. And now let us look at the ground.
Right, so all that's representing is these lines that are going into the Earth, and you're just changing the velocity of the line, okay, which is okay with me, but you still haven't figured out how to explain what it all goes into and where it's all coming from. So again, this curvature thing, giving the curvature motion obligates you to explain where the force came from, where the motion comes from. So you're not even saying space is bent, you're saying space has motion.
Will be the space-time path for the ground? Well, if I get rid of everything, well, the ground is at just rest. It's not moving through space. It is just there. Therefore, the ground should look like this. But let's see what happens when you open it up. Here I have it. I open it up and boom, boom, just shake the room. Say, what? I'm sorry, I got too excited. But what do you see? The ground is curved. It means the ground is accelerating upwards. And now let's think about another patch of ground on the opposite end of the Earth. it'll also be accelerating. I'll just do a mirror image over here. It'll be accelerating the other way around.
Look, I'm just saying, we all understand that's not happening. What's happening is the Earth is being pressurized. Pressure from all directions. It puts pressure on the Earth, and the Earth says, this is as much pressure as you can give me, and I'm going to push back if you add any. So if I poke the Earth from one point, it will pop out at some other point. Like a wave, like ocean water, like water. If I poke my finger into water, the water rises. Well, the Earth is going to do the same exact thing. If I create a pressure imbalance by adding more pressure, it's either going to accept it, like I leave it there, and now it's got a new total pressure, or it's going to reject it, and it's going to sit there and say, no, I'm not accepting your pressure, and then the wave will go around the Earth and come back to you, and it'll push you back out. It'll say, screw you. I'm going to give you your pressure back. So we clearly fall into the Earth, and the Earth pushes us back. We don't feel falling. We only feel the Earth push back. That's the part you feel. That's the part that fatigues your parts, okay, that hurts your body, is the Earth pushing back. Gravity pushing you in, that's for free. The Earth pushing you back, that's painful.
But these two patches of ground will not be moving away from each other. The Earth will not expand because when you fold it, look, in our spatial and ordinary spatial and temporal terms, when we see it, how we experience it.
So it just doesn't mean anything. How does that solve the problem? How does showing me two cones pointed in the opposite direction solve the problem? That doesn't solve any problem. I mean, amazing garbage.
Distance between them stays the same. Why is that happening? It's happening because of curvature of time, because time is curved. We have discovered curvature. So this is how time dilation...
Jesus saves! Jesus is great! Jesus is Jesus, man! Jesus is so cool! Oh, Jesus is so much fun! I mean, this is just a religion, okay? And he's all excited about his religion. He's going to save the world with this silly theory that the Earth expands, but doesn't really do it. Because it's a cone, and cones don't push out, but this little curvy thing does push out. This arrow's going out. The curved arrow's going around in a circle. So therefore, yes, it's pushing out, but it's going around in a circle, so it doesn't know it's pushing out. What the fuck? Talking fish nonsense. Just write a 3 bear story. Come on. Why would bother with this bullshit? Just write us a little silly Sasquatch goes to the drugstore. Fuck. Or to Smurfville. Yes, Sasquatch goes to visit Papa Smurf. Or goes to Papa Smurf's funeral.
Which causes curvature, allows your ground to accelerate away, and yet... when we see it,
and brings a Pokemon with him.
Earth will not expand. Finally comes the question, what does it look like when I put an apple over here? So let's do that. Here is going to be my apple. According to Einstein, this apple will not accelerate. It's just going to stay in put. So let's say it's at rest, because it's going to be inertia. If it's at rest, then it will be only moving through time, and look, the time at this place is somewhere upwards. So it'll move.
So how does this make any sense? He calls this the ground. This is the apple. It just sits there and doesn't do anything. I don't. What the hell are you talking about?
Through time, wherever it is over here, it'll move through time, and it'll continue to move through time only. It'll go like this. It should continue straight line. This is how it will go. So this is what's happening according to Einstein. And now, let us see what happens in our spatial and temporal terms as we see it. As we see it, what do we notice? We see the apple falling to the ground. That's what we see.
Yeah, you drew it that way too. Oh, so let's do that again. Boy, that's just such fun, these little paper tricks. I mean, you know, nothing like a good paper trick. So we see the line is going right to the ground. This is the ground line. It drew it right to the ground, so not a big surprise. When he curls it up, it's doing exactly that. It's going right to the ground. Oh, brother.
Spatial and temporal terms as we see it, what do we notice? We see the apple falling to the ground. That's what we see. The ground stays put.
Yeah, Jesus, woke the dead, and cured the fetters and made fish sandwiches. This is the fish sandwich trick.
The apple is falling to the ground. We see it, we observe it accelerating to the ground because we see it to be curved. But guess what? It's not. It's going in a straight line. It's the ground that is curved. But again, because we inhabit a curved space-time, because of it, the ground appears to be at rest and the apple appears to be falling. So putting it all together, because we see ground to be at rest and apple accelerating down, Newton thought, well, that's basically what's happening. The ground is at rest and the apple is accelerating.
Right, so it's just like the rays of light coming out of the sun, okay? It's what it looks like. Exactly obvious what it looks like. It looks like crap is flying out of the sun and the crap is hitting us. That's what it looks like, and that's what it is like, frankly. It's that simple. The crap goes from the sun to us, all right? And it bounces off us and, can go into your eyeball. And it's all these nice little straight lines. And Newton drew all those nice little straight lines and explained things like a rainbow. Explained exactly how the little angles, the little straight lines are all creating the little change in what frequencies of light it's possible for you to see at what angles and all of that stuff, and explained it perfectly with nice straight lines. So of course straight lines work, and this is the only place this bending crap works. It doesn't work in any other analogy. It doesn't work any other place. It's absolutely nonsense. Forces move in dead straight lines because forces can't do any bent path. They can't travel a bent path. Either can a baseball, for fuck's sake.
But then, because of all the discussion that we thought, Einstein realized maybe that's not the case. Maybe it's the ground that is accelerating up and the apple stays put. The equivalence principle. Now, the moment we do that, this is how we start.
So we know it's not equivalent. We know pushing you by your feet up is different than gravity pushing your electrons and protons down. So those two experiences are different. Being hit by a wrecking ball, okay, is different than being moved by magnetism, for example.
Start thinking about it, right? And as a result, we start wondering, well, if that is the case, then why doesn't the ground, if the ground is moving upwards, the ground is accelerating upwards, then shouldn't the earth expand? Well, the problem is this is not the right way to think about it, because you haven't considered the curvature of time, which is important if you're using Einstein's theory. But when you do incorporate it, you actually see that yes, ground can accelerate up, the apple is inertial.
Yeah, so they're just changing, they're making time into some dimensional space that's absorbing the expansion of the Earth. So the Earth doesn't expand in real three-dimensional spaces. It's only expanding and contracting in the time space. And there is no time space. There is no fourth dimension. The three dimensions have rules. All the dimensions have to be at right angles to each other. All right angles. There's no room for any fourth dimension. So we shouldn't even be having a conversation about any fourth dimensional space, because there's no way to mathematically make a fourth dimensional space that follows the rules of the other three dimensions. But again, it's physics. They don't care about rules. Rules are laws. Forget it. We don't care. I mean, what did Newton mean? I asked this guy, what did Newton mean right under the second law? Okay, his first little corollary, his descriptive statement of the second law. The first sentence says, you want to go twice, you apply twice the force, you go twice as fast. You apply 3 times the force, you go 3 times as fast. Clearly indicating that it's just a change in momentum, that the force equals the change in your momentum. There's no mv squared anywhere. He didn't say, well, you apply 2 times the force, you'll get 4 times the velocity, or 4 times the force is required to go twice the velocity. He never said that.
But when you see it in the ordinary spatial and temporal terms, notice the ground is not moving anywhere. It just stays put, and we see the apple falling down. it all works out.
No.
Do try this at home.
Oh, please, try this at home. You think so? It's going to be that stupid? Shit. Oh, it looks like such fun. I can't wait. That's as good as finding out about masturbation. This is like the happiest day of my life to find out how I can do this little paper trick. Oh, it's going to be so exciting. I just can't wait to show all my friends. I can wait.
Just need some pen, paper, and scissors, and do ponder about it.
I'd have to go find a friend, actually, but whatever. It's going to be really hard to locate one of those. Oh, God, I hate this planet.
Because think about, where did this all come from?
From imagination and bullshit. You didn't have an answer, so you said, well, we have to come up with something, so let's come up with something preposterous. If the glove doesn't fit, you gotta quit. Yeah, how's that? I'll use that phrase. Gotta come up with some kind of gimmick to get out of this thing, reality and such. We're totally defeated because we're too stupid to think of some kind of easy and simple answer. So let's invent some sort of absolute horse shit. And we won't call it gremlin theory, but that's what it really is. The gremlin dimension.
It all came from that one ancient age-old experiment. Why things fall at the same rate.
Right, because this has the same electrons that this has in it. And the only thing being moved are the electrons, and the electrons are all the same size, so they're moving the same speed. This has 50 electrons, this has 674 electrons, therefore it doesn't really make any difference, right? Because, this one collected more energy. When it hits the ground, it's got more electrons moving with velocity, so it has more momentum, and it'll show you it has more momentum by going bounce when it hits the ground. The feather's just going to go poof. So we know it collected more energy, but it's just because, it's got more little bits that collected the energy. So it collected energy proportional to its mass. Proportional to the number of electrons and protons, it collected energy. And they collect the energy at exactly the same rate. 50 electrons collect the energy at the same rate as 500 electrons. It's just that obviously 500 electrons collect more energy. Their total momentum will be higher, but the thing moving, the electrons, are moving at exactly the same speed.
And I find that absolutely fascinating. So it's the time curvature, folks, that is responsible for...
Yes, well, whatever. It's the God. God done it. God is great. Love, love. God, God. Jesus, Jesus. Whatever. Mohammed. Blah, blah, blah. Bullshit, bullshit. Just a frickin' religion.
Almost all the effects of gravity that we see in our everyday life. It's a time curvature that gives you orbits. That's another reason.
Yeah, you want to bet? You want to bet? Yeah, I wish I could bet on it. I wish there was some way to make all of these people poor in the future, where they'd have to pay back the debt, because it's going to be known that this is horse shit. This is a bullshit explanation. This doesn't have anything to do with the nice, simple reality. The Earth is excreting less pressure than went in. And the simple fact is, it's fucking on fire. Okay, the inside is burning. What's keeping the flames burning inside the Earth? Well, I guess that's the mechanism making the gravity. Oh, Jesus. That's the deficit in the energy.
Why I hate that rubber sheet analogy, because it shows spatial curvature giving orbits, but it's not true. It's the time curvature.
Oh, whatever. It's not even accurate is the point. That thing isn't accurate. It's got way too much friction in it. It slows everything down. It doesn't really create anything that is like the reality. The reality is you put it in, it either hits the center thing, bang, or it flies out. It doesn't ever orbit.
And that's responsible for all orbits as well. Now, speaking about orbits, turns out that Mercury's orbit is a little weird. It actually precesses, but why does it happen?
Simple explanation is the sun, this big, giant, huge ball of stuff on fire, is itself precessing. So the sun has a little precession in its mass. So it's wobbling a little bit. And the planets far away can't feel it because they're really far away compared to Mercury. Mercury's like really close. And then Venus is really kind of far away, and the Earth is, so the other planets are much further away. So Venus feels the precession because it's really close. That simple explanation is a viable explanation. So it works. You just give the sun enough precession to screw up Mercury, and it won't be enough precession to screw up anything else. But no, that's too simple an answer.
After accounting for all the gravitational influences of other planets, it doesn't account for how much precession we see. So what's going on? Well, you can probably guess it. Spatial curvature. But what's the motivation for that? How do we again...
Yeah, and why can't any of you ever do the math all the way through? Nobody ever does it. They just say, well, the gamma factor is this. They never actually try to calculate it and actually get the answer. So you never see anyone go from, here's where Mercury is, here's where Mercury will be in 3 days. Now I'm going to explain why it's a little bit off. They never do that, ever.
Rediscover it from first principles like we did over here. Well, we're going to do that in the next video. And if you want to stay notified, we'll just subscribe to my channel. But if you don't, it's fine. It's completely fine.
Yeah, no, I'm not subscribing. That's right.
Stay.
Yeah, thanks. Fuck you. Anyway, Schrodinger's smiley. So again, do you think Schrodinger would be happy for you to pretend that Schrodinger actually thought there was superposition when clearly Schrodinger was saying that's a pile of shit? The whole point of Schrodinger's cat was to mock how silly the theory is. And here you are, So, I mean, you really don't care. You'll just piss on any old dead people, right? Just make jokes about dead people. Turn dead people into jokes. That's just kind of slimy, frankly. Okay, so, I mean, we should try to be fair to people of the past and describe their dilemma fairly, and their identity fairly. Newton wasn't a kinetic energyer. He wasn't a Leibnizian. And he was in fact right. And you people are in fact wrong. And I hope you get mocked in the future, frankly. I hope somebody distorts everything you said and then makes a t-shirt with all those distortions and just said, look, this guy believed in, whatever. Just come up with the appropriate crime of some kind. Pinching girls' bottoms. He was a girl bottom pincher. Just turn him into some kind of villain or fool. Because you can, not because you should. All right. So a little preaching. Yeah, sorry. I just find it disgusting that people take these images of Einstein, they take these comments and words, and they pervert all of the history and distort all of the history when they should really be wearing a Leibnizian shirt. They should say, I'm a Leibnizian. I believe in solitons and monads. Fuck. Fuck. So I'll ask this guy again, another simple question. Do you really believe, that 4 pounds dropped 1 foot is the same impact energy as 1 pound dropped 4 feet? Do you really think so? If you had the choice of having one or the other dropped on your head, would you choose the 4 pounds? Yeah. Is there some way? I'm going to make the 1 pound a little bit lighter. Okay, so I'll make it just a teeny bit lighter. So now, heavier. So now you have an incentive, right, by your theory to choose the 4 pounds. So are you still going to choose the 4 pounds? Dropped 1 foot. Are you? Can I make it a real experiment? Okay, is there some way to make this real, like, the real difference between a concussion and just a little knock in the head? Can we really make the experiment and then see if these people will really put their money where their mouth is, the safety of their brain, where their shit talking is? Because yes, obviously the 4 pounds is in the gravity 1 second, and the 1 pound is only in the gravity 2 seconds. So 2 times 1 is only 2. And obviously 1 times 4 is 4. Do you disagree? Okay. Jesus. In the 350 years of the kinetic energy theorem, do you really have any experimental evidence? Anything to show me? A car crash? Anything at all to show me that a car going 5 times as fast does 25 times the damage? now. You can't show me any of it. It's all bullshit. All right, anyway. Till the next time and such, see if we can get anything out of him as a response. I think I've emailed him before, but I'll do it again. You know, what the fuck? I'll just make a record of all of it, right? So I did challenge all these people. I asked them, how much do I have to pay you? So again, I'll say it to you. How much do I have to pay you? I'll pay you, okay, for your video time. So just tell me how much it costs for a 10-minute video response, a 15-minute video response, where, you know, you play a 5-minute video of mine and then you explain how my, you know, in the next 10 minutes how my video is wrong. You know, that kind of thing. How much do I have to pay you? All right, to respond to my accusation that your physics is nonsense. It's a religion. It's a fable. It's a fairy tale. It's under-evidenced, made-up crap. That's the accusation. Do you have anything to say in your defense, or will you just ignore the accusation, of course? Just ignore. Run away. Run away. Then how much do I have to pay you not to run away? I'll pay you. It's just a fact. You can probably come up with some crazy numbers, and I will raise the money. So let's see you do it. Let's see you have first the embarrassing, you know, see how much you can embarrass yourself by claiming your time is worth, you know, $1,000 a minute. Go ahead. Give us some outrageous claim about what your time is worth. All right. So anyway, what your physics time is worth.